Welcome to Numerical Methods, Pseudocode Conventions, Part 2 of 3. In this video, pseudocode conventions for while, repeat until, and for loop constructions are presented. In computer programming, control constructions, often referred to as control structures, are essential components that dictate the flow of execution in a program. They allow a program to make decisions, repeat actions, and perform different operations based on conditions or iterations. Control or loop constructions are used when a program needs to execute a block of instructions repeatedly until a condition is met, at which time the loop is terminated. Control structures commonly used in programming languages are covered under 3 headings in the adopted pseudocode convention: while, repeat until, and for loops. Each language has its own way of handling control loops, but the basic principles are quite similar to the pseudocodes presented here. For example, the C language has the following loops: for loop, do while loop, and while loop. The Python language primarily supports 2 types of loops: for loop and while loop. Python also provides control statements to modify the flow of loops, such as else, break, or continue. See the supplementary material provided for Python programming language on the following GitHub site. MATLAB also supports 2 types of loops: for loop, while loop. These loops can also be modified using additional control statements, such as break, exit, etc. A GitHub site dedicated for the textbook activities has been created where additional learning materials, source codes, videos, etc. are provided for students using the text. You can also find supplementary materials provided for C, C++, Python, Fortran, Visual Basic, MATLAB, and Mathematica programming languages. The pseudocode syntax for the for loop construction is depicted as follows. Note that this construction is delimited by for and n4 keywords. Also see the corresponding flowchart illustrated on the right-hand side. In this example, the loop index or control variable is I. The loop index takes values corresponding to delta I steps, starting from I1 to I2. Here's, step by step, how for loop works. At the start of the loop index I is initialized to I1. A control check is carried out before each iteration of the block statements. If the condition evaluates to true, the block of code inside the loop, that is, the block statements, are executed. Here, the condition that checks whether I is less than or equal to I2 is evaluated. For I equal I1, this condition evaluates to true. In this case, the block of code is executed. After each iteration of the loop control variable is updated, usually increasing or decreasing its value. This is done by setting a positive or negative increment to delta I. Note that if delta I is negative, then I1 should be greater than I2. At the top of the loop, the control variable after one iteration becomes I1 plus delta I. The loop condition is checked. For any I less than I2, the condition evaluates to true. Then, the block of code is executed for the new I value. Overall, the loop index takes values corresponding to delta I steps, starting from I1 to I2. For I equals I2, the new index becomes I2 plus delta I. After each iteration, the condition is checked, and this process repeated until the condition evaluates to false. When the control variable I reached I2, the loop index was updated as I2 plus delta I. In this case, the condition evaluates to false. The loop goes to N4 and terminates. The control passes to the line of code following the loop. Now, let's see how this loop works with a numerical example. The following loop runs from 1 to 5. Since an increment or decrement value is not specified explicitly, the default value of +1 will be used. So the loop starts with I equals 1, since the index value is less than 5. The write statement in the code block is executed, and the value of I is written on an output device. Next, the loop index I is incremented by 1, which makes it 2. The index value is less than 5. Thus, the code block is executed and the value of I is written on an output device. The loop index I is incremented by +1, which gives 3. And this process is repeated until the loop index becomes 5. For I equals 5, the write statement in the loop block is executed and the value of I is written on the output device. The loop index is incremented again to give 6, and it goes to the top of the loop with its current index value. Where I less than or equal to 5 condition becomes false. Thus, the code block is skipped and the loop is terminated with the N4 keyword. The next executable code statement writes the value of I on the output device with the label last. Since the current value of I is 6, the written value is 6. Now let's consider the following code with a specified increment. The loop runs from 0 to 5 with an increment of +2. The loop starts with loop index of I equals 0. I equals 0 is less than 5. So the code block is executed and the value of I equals 0 is written on an output device. Next, the loop index I is incremented by 2, which makes it 2, which is less than 5. Thus, the value of I is written on the output device. As the loop returns to the top, the loop index is incremented by 2, which becomes 4. For I equals 4, the write statement is executed and the value of I is written on the output device. The loop index is incremented again to give 6, which is greater than 5. That means the condition evaluates to false. In this case, the write statement is skipped and the loop is terminated when it reaches the N4. The next executable code statement writes the value of I on the output device with the label last. A while loop is common to many programming languages. The pseudocode syntax, as well as the corresponding flowchart, is shown. A while loop, unlike a for loop, does not require a control loop index. The loop starts with the keyword while. In while loop, a condition is evaluated first. The condition can be constructed based on any logical expression, such as if a variable or arithmetic expression is smaller or larger than a specified value, and so on. If the condition is true, the block of code statements within the loop is executed. Then the loop is directed to the top, where the condition is rechecked. If the condition evaluates to true, the loop executes the block statements. The block statements are repeatedly executed as long as the specified condition remains true. Once the condition evaluates to false, the loop reaches end while and terminates. Then, the control passes to the next line of the code that follows the loop. Now, using a numerical example, let's see how the while loop works. The following is a pseudocode of a while loop. The main variable I is initialized with 1. The control statement is I less than or equal to 5. The code segment consists of statements that include writing and incrementing I. The loop evaluates the condition first. Since I equals 1 is less than 5, the condition evaluates to true. The write statement in the code block is executed, and the value of I is written on an output device. The index variable I is incremented, thereby its memory value becomes 2. Next, the loop makes it to the top, where the condition is reevaluated. Since I is less than 5, the logical expression evaluates to true. Therefore, the code block is executed to write the value of I on the output device. And I is incremented by 1, which gives 3. And this process is repeated until the loop index becomes 5. For I equals 5, the loop condition is also true. Then the first statement of the code block can be executed. The value of I equals 5 is written to the output device. The index variable I is incremented to give 6. The loop visits the condition statement at the top of the loop. The condition with the current value of I equals 6 evaluates to false. As a result, the code block is skipped and the loop is terminated with the end while statement. The next executable code statement writes the current index value of 6 on the output device with the label last. A repeat until loop is also a control flow structure, and similar structures are common to most programming languages. The pseudocode syntax, as well as the corresponding flowchart, is shown. Any loop that carries out this function allows a block of code statements to be executed repeatedly until a specified condition evaluates to true. Unlike the while loop, which evaluates its condition before executing the loop body, the repeat until loop evaluates its condition after executing the code statements. This ensures that the loop body is executed at least once before the condition is checked. Repeat marks the beginning of the loop. Statements is the code block that will be executed in each iteration of the loop. This structure ensures that the code statements inside the loop are executed at least once. Until with the loop condition marks the end of the loop and specifies the condition to be evaluated. The loop continues to execute the code block as long as this condition evaluates to false. When the condition becomes true, the loop exits and control passes to the next code statement following the loop. With a numerical example, let's see how the repeat until loop works. The following is a pseudocode for a repeat until loop. The main variable I is initialized with 1. The code segment consists of statements that include writing and incrementing I. The control statement is I greater than 5. In this construction, the write statement is executed first, and the value of I is written on the output device. In the following line, the variable I is incremented, thereby its memory value becomes 2. Next, the loop condition is evaluated. Since I equal 2 is not greater than 5, the condition evaluates to false. Now, the loop goes to the top and writes the current value of I, and then I is again incremented by 1, which gives 3. Since I equals 3 is not greater than 5, the logical expression evaluates to false, and this iterative process is repeated until I equals 5. Incrementing I leads to 5. For I equals 5, the condition also yields to false. Thus, the loop starts from the top again. The index value of 5 is written to the output device. The index variable I is incremented to give 6. Now, the loop condition evaluates to true since I equals 6 is greater than 5. As a result, the loop is terminated and control passes to the next executable code statement, which writes the current value of 6 on the output device with the label last. A pseudocode and the corresponding flowchart for a for loop with an exit statement are illustrated here. In many programming languages, exit or break statements are used to control the flow of loops. In this pseudo-coding convention, exit function is synonymous to break. In various programming languages, these keywords may serve different purposes. The exit statement is used to break out from a loop prematurely. This is useful when the analyst wants to stop the loop based on a certain condition. A condition is evaluated inside the loop. Depending on the algorithm requirements, the condition may be placed at the beginning, in the middle, or at the end of the loop. In this code segment, the condition is evaluated somewhere in the middle of the for loop block containing the code statements. If the condition evaluates to true, the loop goes directly to N4, skipping the remaining code statements, and the loop is terminated immediately. If the condition evaluates to false, the control flow continues with the remaining statements. In this example, the for loop runs for index values from 1 to 10. The exit condition is I equals 5. The loop runs from 1 and writes the index variable I to the output device. Since I is not equal to 5, the loop goes to the top. With I equals 2, the process is repeated until I becomes 5. Here, for I equals 5, the loop terminates without going to the top. Therefore, the loop counter is skipped. That is why the current value of the loop index remains unaltered. Thus, it preserves the memory value of 5. That is all for now. See you next time with another topic. Bye.